So this will be our equilibrium price, P star. How to find equilibrium market quantity that will be bought and sold? You can put this 700, this price, into demand function or supply function. For example, I put into demand. This is 500. So where is our answer? This and this, 4.8. Guys, please questions, is it clear? Okay. So good. Then let's draw the graph. Let's illustrate. We draw market. Here will be a price, vertical axis, here quantity. So our demand function, 1,200 minus price. This is linear function with negative slope, so 2 points. If price is equal to 0, quantity is equal to 1,200, put here. If quantity is equal to 0, price, maximal price will be equal to 1,200. See. Linear function. This is the demand. What about supply? Market supply. So quantity supplied in the market will be equal to 0 if price less than 200. So put this 200. And if the price is lower than 200, quantity supplied is equal to 0, vertical part. Then price minus 200. The slope, positive slope, with the slope equals to 1. So it's something like this. When we cross them, we got the equilibrium. This Q star equals to, we counted 500. Price equals to 700. Then, in this task, we are asked to show consumer surplus and producer surplus. What we know about consumer surplus and producer surplus? Consumer surplus is the sum of, benefits, net benefits of all our consumers. How to understand where to show? We know that, for example, the first unit, our consumers were willing to buy for very, very high price. By definition, inverse demand function that is showed here, inverse demand function by definition is the maximal willingness to pay for each unit. Yes? So we were ready to pay very high price, but we paid only equilibrium price. And this difference between maximal willingness to pay and the price that we actually paid, we like this difference. Yes, so it goes to our net benefit. So pluses, this we like. And this we can say about each unit that we bought. So the area under the inverse demand function and the price that our consumers paid is consumer surplus, this triangle. We can count it. So consumer surplus equals to how much? The area of triangle, 1/2 multiplied by the height 1,200 minus 700, multiplied by the base is the quantity, 500. It is equal to over 2. Okay, this. What about producer surplus? Let's see.
Where did the half come from?
It's the formula for the area of triangle.
Got it. Okay.
One one half multiplied by the base multiplied by the height.
Yeah,
Okay.
yeah. I completely forgot it's triangle. Yeah.
So then, what about producer surplus? Producer surplus, it's the sum of variable profits. But let's see. In the market, sellers, the first unit, for example, they were willing to sell for the minimal price very low, but they sold for higher price, for equilibrium price. And this difference, this profit margin, they like it. So, and we can say the same about each unit that they sold. So the area under the equilibrium price and above inverse supply function is the producer surplus, is the net benefit, total net benefit of our producers, producer surplus. How to count? Okay, let's see, consumer surplus S producer surplus. How to count also? 1/2 multiplied by the height. The height is 700 minus 200 multiplied by the base 500. The same as consumer surplus, the same number over 2. Okay, and we can count the social net fare, social welfare. Social welfare, by definition, is the sum of surpluses of all economic agents that are presented in the market right now. Now, here are only 2 economic agents that are presented, our consumers and producers. So we sum up their surpluses, consumer surplus plus producer surplus. And we see that social welfare is 250,000. And we know that in perfect competitive market, if government does not intervene, the social welfare is maximal. So the sum of green triangle and the red triangle is the social welfare of our society right now here. Then, next part. Please, questions about this? Okay.
So social welfare is basically the meaning the gain that both the consumers get and the sellers get.
All economic agents that are presented in the market. If there will be government, we should sum up also the government surplus.
Can there be examples where the consumers win, the sellers win, and the government wins?
What means wins? They have surplus.
Well,
Yes?
there's social welfare for all 3 parties at the same time.
Okay. When government imposes the tax, and the tax revenue of the government is the surplus of the government. Okay.
But can there be social welfare for all 3 parties at the same time?
Yes. So if government imposes the tax, there will be consumer surplus plus producer surplus plus tax revenue. It's the welfare, the surplus.
Okay, got it.
Good question. Thank you. So let's see. Next point. Point C. To protect the poorest consumers of Marshallia, the Supreme Marshal introduces a price ceiling. No picking in the country can be sold for a price above 400. So this is government intervention, price ceiling. So maximal price that can be posted is 400. And we should calculate the social losses from this intervention. So we see that without government intervention, our equilibrium price is 700. Yes. So, but maximal price right now is 400. So we cannot price 700 cannot be here. What we will see with this maximal price that can be in the market? What about quantity demanded with such low price? How much? 1,200 minus 400. It is 800. This how much consumers wants to buy for this maximal price. What about sellers? Mm-hmm. 400 minus 200. But only 200 units our sellers wants to sell. So we see that quantity demanded is bigger than quantity supplied. So we will have deficit. Yes, here, like in USSR. Deficit will be how much? 800 minus 200. 600. What about equilibrium price in this situation? It cannot be higher than 400, so the equilibrium price will be 400. What about equilibrium quantity that will be bought and sold? Who can tell me in such situation? We have two options, 800 or 200. How much will be bought and sold?
200.
200, yes, the minimal. Yes, consumers wants to buy 800, but they cannot. Yes, they can buy only 200. So this will be the equilibrium quantity. Exactly. This will be quantity supplied out of 400. This is 200. Yes. So let's show on the graph this situation. I will draw one more time the graph. Here demand, here supply, and we show this government intervention price ceiling, maximal price 400. It is, we know that it is lower than 700, so let's put it somewhere here. For such price, quantity demanded with price 400, quantity demanded will be equal to 800. Quantity supplied will be equal to 200. This difference is the deficit. And where is the equilibrium point? Equilibrium point is here. Yes, this is Q star, quantity that will be actually bought and sold. And this is equilibrium price with this government intervention. Okay, so what we can say right now about consumer surplus, producer surplus, and welfare losses. Producer surplus, by definition, is the difference, is the area under equilibrium price, under the price that our sellers will put into their pockets, yes, and the minimal price that with which they were willing to sell their good. So the area under P star and above inverse supply function. So this is producer surplus.
So we will be at 1/2 times 400 minus 200 times
200.
200. Yes.
Yes, exactly. And we see, if we compare, we see that producers are worse off compared to the situation without government intervention. Yes? You see, this triangle is bigger than this triangle, but we can count it. Yes. It's less than it was before. So we make the conclusion that producers are worse off. Then, what about consumers? Consumers, they buy right now 200, but for the lower price than before. Yes? So the area under the inverse demand function and above the price that they actually paid is the consumer surplus. And we see that it's not triangle right now, but the trapeze. We can calculate the area of the trapeze. This is the 1/2 of the sum of two bases. First base is 1200 minus 400 plus the second base. How to find the second base? We should put this quantity 200 into the demand function. Easy. 200, this note, 200 equals to 1200 minus price. So the price, maximal willingness to pay for such quantity is 1000. So here 1000 is minus 400 multiplied by the height 200. Let's calculate. 100. You see, 280 thousandths over 2, and this is bigger than before the government intervention. So after such policy, consumers are better off. We can calculate social welfare after such government intervention. Social welfare right now. Here, only consumers and producers have the surplus because the government does not earn or spend money, yes, for such policy. So this consumer surplus plus producer surplus. 80 thousandths over 2 plus. And this is 32 over 2.
I think you missed the 0 on the 28,000.
Yeah, thanks. Yes. And this are how much? 16. And we see that social welfare is lower right now. It is less than before. So we can say that we have dead weight losses. The society loses how much? So society is worse off in total, yes? So dead weight losses equals to this difference.
90,000?
Yes, yes. This is the dead weight loss. Where we can show it on the graph. You see, before the government intervention, we had social welfare, green triangle plus red triangle. This part was social welfare. And now we have this trapeze. Yes. So this white triangle, right now, I will make it black. This is the dead weight loss of society after government intervention. Adam Smith told us in perfect competitive market, government should not intervene for not having losses for society. But anyway, consumers are better off. Yes, but producers are worse off. And society in total is worse off. Here. I think that's all about this task. Please, questions?
Can I ask a question about the when we were counting consumer supply? I didn't get, where did you take 1,000 from? Because I know the formula is 1/2 multiplied by A plus B and multiplied by the высота, right?
Height, yes. You see, okay, this is our trapeze, yes? This is height, this is A, this is B, yes? So about B, we know the difference, 1,200, and here 400. So B is equal to how much? 800, yes? What about A? We know here 400, but this we don't know. How to find? We know this point. Quantity demanded here is equal to 200. Yes, put this quantity demanded into maximal willingness to pay, into inverse demand function. One more time, market demand 1,200 minus P. Yes? So if quantity is equal to 200, what is the number for the price? So the price from here is equal to 1,000. So this is 1,000.
Yeah,
1,000.
thank you. Thank you. Now I get it.
And A will be equal to 600. And height, we know height equals to 200. Good? Good question. Thank you. So, okay, guys, please, let's move on because we have our next class. Please open the third problem set. Today we will speak about preferences of our consumers, about indifference curves. So let's see. Our first task is about indifference curves. Draw the indifference maps for the following preferences among consumption bundles of fish and chips. So we have two goods, X1 fish, X2 chips. For the following preferences, point A. What about Anna? Anna loves fish and is indifferent to chips. So Anna loves fish, X1, and indifferent. Extra fish always makes her happier, irrespective of the quantity of chips she has. So, what is the definition for indifference curve? Please, who can tell? what we should draw. Alex, you answered. Who wants to answer also? No, nobody. Okay.
Yes, for
Alex?
this case, as I understood, the curve for fish will be just vertical.
Yes, thank you. I will explain right now. So, first of all, we draw the graph and name the axis. So here we will have fish, here we will have chips. How to draw the indifference curve? On the indifference curve, we have there lie bundles. For each of them, we will get the same level of utility. Yes, the same pleasure, the same net benefit, something like that. So how to draw it? Let's take any bundle, put the point, and we should find another point that will lie at the same indifference curve that will give us the same pleasure, the same utility level. So if, for example, I will give to Anna more fish, if I will move to the right, she will be better off because she loves fish, yes? So this new point will not lie on the same indifference curve. This point to the right will give her more pleasure. So this point we do not take. Okay. If we will give to Anna more chips, she is indifferent with chips, so her utility level will not change. The pleasure will stay the same. Agree? So the point that lies above the first lies at the same indifference curve. And we understand that our indifference curves for such preferences will look like vertical lines. This is, for example, indifference curve 1. Always name the line. And we should show an indifference map. So at least 2 indifference curves. For example, this indifference curve I see 2, indifference curve 2 will give us a higher level of utility. Agree? But that's not all. We should show that direction of the utility of pleasure grows. The direction of pleasure grows. We know that where our utility grows, to the right. Yes. More fish will give her more utility. So show this arrow. Black, but with pencil. Notebooks. So here, utility grows. So this is how you should draw this indifference curve map. Please, questions about this point A? Okay, got it, yes? Okay, point B. In point B, let's see. Boris is always ready to exchange a maximum of 2 bags of chips for 1 fish. Boris ready to exchange maximum of 2 bags of, let's write exchange. 2 bags of chips x2 for 1 fish. Extra fish or extra chips always make him happier. This we can conclude from this information. We can conclude that fish and chips for Boris, they are goods, not bad. More is better. So how we call such goods, such connection?
Perfect substitutes.
Perfect substitutes. Yes, thank you. And let's draw. x1, x2. So let's start from exchanging 2 chips for 1 fish. If I will have only 2 chips, let's put it here, for example, 2. I will be indifferent, yes, if I will exchange these 2 chips for 1 fish. So if I will have only 1 fish, it will give me the same level of utility as 2 chips. So these 2 points lies at the same indifference curve. If I will exchange, for example, 4 chips, for what amount of chips I should exchange it?
2.
2, yes. So the proportion stays the same. So, and all these points will give me the same level of utility. And also we know that more fish and more chips gives to Boris more utility. So the direction of utility grows to the right and up. Name our indifference curves. IC1, IC2. But it's only illustration. We know that there are infinite number of indifference curves. Yes. A, B, C. Christine consumes fish and chips in fixed proportion. She likes each fish to be accompanied by exactly 2 bags of chips. Otherwise, she just won't eat them. Christine likes fish to be accompanied by exactly 2 bags of chips. So 1 fish accompanied with 2 chips. How we name these 2 goods?
Perfect complements.
Yes, perfect complement. Let's write down this. And here were perfect substitutes. Do you know how indifference curves for perfect complements looks like? Yeah. It's like angles, yes? Let's draw. And I will explain why is it so. So here fish, here chips. This for Christine. Let's give to Christine 1 fish and 2 chips. 1 fish and 2 chips. Put this point. Let's start from this point. So if we will give her more chips, she will be better off, worse off, or she will be indifferent. To 1 fish, we will give her more chips. She will be better off, or worse off, or indifferent. Who can answer?
Probably indifferent.
Yes, she will be indifferent.
Because she demanded one pack of chips accompanied with one fish accompanied with 2 pack of chips. Yeah.
Yes, and here we see she likes each fish to be accompanied by exactly 2 bags of chips. Otherwise, she just won't eat them. Yes. So if we will give her, for example, 3 chips, 3 bag of chips, the third one she will not eat it. Yes, because she has only 1 fish right now. So this point lies at the same indifference curve. Let's start from our point 1 to one more time and give her two bags of chips, one more fish. She will be better off, worse off, or indifferent.
Probably worse off.
Why? She has two bags of chips and, for example, 2 fish.
She would be better off?
Oh, better off, yeah.
No, she will be indifferent because she will not eat this second fish because she has only two bags of chips.
Yes.
Agree? Because she, one more time, 1 fish accompanied with 2 chips.
She will only consume this chips and fish if she has like 2 packs of two fishes, 2 packs of fish and 4 packs of chips, right?
Yes.
Okay.
This point lies also at the same indifference curve. So we see that indifference curves for perfect complements, they look like angles. If we will give her 4 bags of chips and 2 fishes, she will be better off. We know it. Yes? And also all other points lies at the same indifference curve for higher level of utility. So this is indifference curve 1, indifference curve 2, and we see that these exact angles, they lies in this like line with positive slope, and the slope is this proportion 2 to 1. Yes, all these angles, they will lie in this line with positive slope. Direction of the utility grows to the right and up. Is it clear? I think it was in the lecture about perfect complements, perfect substitutes, and something like that. Okay. So, thanks. Let's do the next. Point number 2. Consider a person whose preferences for marmalade and spending on everything else are described by the following utility function. So we have good x1 marmalade, x2 everything else, and the utility function. Utility level depends on the consumption of good 1 and good 2, equals to x1 multiplied by x2. You see that this function is the function of 2 variables. Yes, not 1, but 2 variables. Write down the equation for the indifference curve passing through point 2, 4 and draw this indifference curve. So we should take the point 2, 4. It is x1 marmalade equals to 2. Everything else equals to 4. Who knows how such indifference curve will look like? Who can answer? What is the shape of the indifference curve?
Like a slope.
Like what?
A slope, дуга.
Yeah. Yes, thanks. So we have 2, 4. Put this, so utility level to the point 2, 4 will be 2 multiplied by 4. It is 8. Yes, this is the utility level that we will get from consumption of such bundle. So 8 will be equal to x1 multiplied by x2. always draw the indifference curves. We have good x1 on horizontal axis and x2 on vertical axis. So let's find x2 from here. x2 will be equal to 8 divided by x1. This is the graph for such function is hyperbola. No? Hyperbolic function. Put this point 2, 4. And we know that this point belongs to our indifference curve that looks like hyperbola. This is indifference curve. What else we should show? Highlight or draw this indifference curve. Is it clear how we draw it? How we understood the shape from math, from calculus? Okay. On your graph, highlight all consumption bundles that are at least as good as 2, 4. What I should shade? At least as good as. We see from utility function, we see that more marmalade gives us higher level of utility. Yes. And at the same time, more of everything else gives us higher level of utility. Yes. So consumption bundles that are better off for us, at least not worse off, lies where? To the right and up, if we compare with our indifference curve. Yes. More is better. It's strict. Here is strict monotonicity. More is better. So all the points that lies above our indifference curve and at least not worse off. Yes. That are at least as good as. So our indifference curve also belongs to this area. So this area, at least as good as 2, 4. That is about number 2. Please ask. Clear? Yes. So next. Number 3 is about not preferences, but how much money we have and what prices we have in the economy right now. It's about our budget set, number 3. What is the task? A local telephone company offers 3 pricing options. So option 1. A monthly fee of $20 plus 5 cents per call. Fee 20 plus 5 cents per call. $20. 5 cents is how much? $0.05. Yes. Per call. Per unit price also. Option 2. No monthly fee, but 10 cents per call. No fee plus $0.1 per call. And option 3. No monthly fee, and 20 cents per call for up to 100 calls, and 5 cents per call for any calls beyond the first 100. No fee. And 20 cents per call for up to 100 calls. How to write down it? $0.2 per call if number of calls for example x1 less or equal than 100, and 5 cents per call for any calls beyond the first 100 if x1 greater than 100. Let's say that x1 is the number of calls. And x2, good x2, everything else. Now that the person can avoid blah, blah, blah. Not interesting. Consider a customer with standard preferences that allocates his monetary income of 100 between telephone calls and spending on all other goods. What information we also have? Income equals to $100. And also we have standard preferences. What that means? That our indifference curves will look like this. Standard preferences. Point A. How would his budget set look under options 1, 2, and 3? Illustrate. Let's draw the graph with axis. Here x1, here everything else. What we know about budget constraint, about budget set? Our expenses should not be higher than our income, yes, for our budget set, yes. So what about the first option? We should pay $20 only if we make these calls. So how to write this? For example, also let's suppose that price of everything else equals to 1. We normalize because it doesn't matter for us. So if we make any call, we will pay how much per call in first option? $0.05 multiplied by the number of calls by x1. These are expenses, our expenses in dollars for calls, plus our expenses for everything else. Price for everything else is 1 per unit multiplied by x2. These are our expenses. And they should be less or equal to how much? What I should write?
$20.
100. 100.
No. We have fee also.
Fee is our income.
No, fee, we should pay this fee. So here will be our income 100 minus this fee 20. Minus
yes,
20.
Yes.
And this is true only if we make we make calls. So only if x1 greater than 0. Agree? And if we do not make calls, if x1 equals to 0, we should not pay the fee. So we will spend only 0 plus x2. We will spend money only on everything else. This is the expression for budget set 1. Let's draw in the graph. So here will be, this is 80. So if x2 is equal to 0, if x2 is equal to 0, x1 will be equal to, let's make note. x2 equals to 0, x1 will be equal to 80 divided by 0.05. This is how much? Let's see. One
1,600.
Yes. So this is our maximal amount of calls with such tariff. And if we do not make calls, x2 will be equal to 800 for this part. But this point does not belong to our budget set. It's our budget line, and x2 less equal to 100 if x1 equals to 0. So we start from 100 less equal than 100 if x1 is equal to 0. So our budget set look like this. This is for option 1. Next. Option 2 easier. Who can tell me the expression for budget set? Please. For option 2, no fee plus $0.1 per call. What I should draw expenses should be less equal than my income.
0.1 multiplied by x1. And plus 1 multiplied by x2.
These are all my expenses, and they should be less or equal than how much?
100.
Yes, it's all my income and we have no fee. Exactly. Easy. So 2 points. 1 point. If x2 is equal to 0, x1 will be equal to 100 over 0.1, 1000. Put somewhere here. And if x1 is equal to 0, x2 equals to 100. Here. This is budget line for option 2. It's the easiest one. And the third option, we have here 2 parts. We will pay no fee and 20 cents per call if x1 less or equal than 100. So let's write down this part.
It should be like a system of.
Yes, yes. Let's write down this system. So I pay 0.2 per unit, yes, multiplied by x1 plus x2. This should be less equal than no fee than 100, only if x1 less equal than 100. Agree? And the second part is the hardest. Any suggestions, please?
0.05 multiplied by x1.
Then?
Plus x2.
Mm-hmm.
And more than 100.
100, but what we forgot is typical mistake to stop here.
It's something to do. It's some 20 cents per 100 calls.
Yes, because we paid for 100 calls, we paid 0.2 per call. Yes, so we should our income now is not 100, but minus 0.2 multiplied by 100. And extra calls, for extra calls, we pay 0.05. Yes, thank you. Good. This is if x1 greater or equal than 100. Thank you. Good. Also, you can express this. I think it's for me, it's easier to write down like this. 0.05 multiplied by x1, it's the total amount of calls minus 100 that we actually paid for these calls. Yes. Let's see. No, we also forgot here. We also forgot here also a mistake. Here should be plus 0.05 multiplied by 100. So for
Why?
easier, you pay 5 cents for extra calls. Yes, for extra calls. So high amount than 100. This is the total amount of calls plus x2. And this should be less or equal than 100 minus that you paid for this call, 0.2 multiplied by 100. And this is if the total amount of calls greater than 100. These extra calls. This, because we paid 0.2 per each out of first 100 calls. So to pay for extra calls, we have only this amount of money right now. Is it clear right now? Because when we open the brackets, here, we can put to the other side and put here plus 0.05 multiplied by 100. Because we did not pay for this first 100 units, 0.05. So we should add this sum to our income. We paid for first 100 units, 0.2 per unit. Okay? No.
Yeah, it makes sense.
So let's draw these two parts. So here, if let's put this 100, yes. Because we will have two parts. Then, if x2 is equal to 0, if x1 is equal to 0, x2 will be equal to 100. So we start from this point. Then, if x1 is equal to 100, x2 will be equal to how much? X2 equals to 80. 180.
Can I ask a question? Why should we like make x1 equal to 0 when we are solving this problem?
We should not make it because we need 2 points to draw the line. For me, it's easier how to draw by 2 points.
Oh,
so
okay. For instance, we can take 0 and 1.
We can, yes, you can take any points, but for simplicity, we take this x1 equals to 0 and the maximal equals to 100. Then draw the line.
Okay, thank you.
So this part and the next part, here we should calculate, yes. Let's calculate how much. 80 plus 5, yes, 85 in total. So if x2 is equal to 0, x1 will be equal to 85 over 0.05. And this is, I will tell you, 1,700. This is option 3. And then let's answer our questions in this task. Show graphically that a person might choose more calls under option 2 than option 1. More calls under option 2 than option 1. What means to choose? It means to maximize your level of utility subject to your budget constraint. Yes? So, how we maximize our utility? If we have, for example, such budget constraint, yes, we should take the highest indifference curve. The highest indifference curve will give us the maximum level of utility that we can get. So we will not take such indifference curve. We will take the indifference curve that touches our budget line. Yes, this is our optimal point. We have standard preferences. So what means to choose? Choose more calls under option 2 than option 1. Under option 2, more calls than under option 1. Let's take under option 2, we will take, for example, here, the last touch. And under option 1, I don't know. No, but where to show? Like this. Under option 2 here, the last touch. Under option 1 here. Utility grows here. So you see that under option 1, we choose less calls than under option 2. Here are last touches of indifference curves with budget lines. These are optimal points of our consumption. This is for our point B. Explanation for point B. C. Show graphically that a person might choose not to have any phone service under option 1 while choosing service under option 2. This situation is also possible. under option 1, we can choose no calls. Where we'll choose it. We don't have more colors. What to do? Okay. So no calls under option 1, where it will be. So we're here. And we will spend all our money. So difference curve is here. And under option 2, we will have calls. More is better. This for C. I think you don't see anything on this graph. Point C, I will draw one more time. Here 100. This is for option 2. For option 1, not like this. And we can and we should show that person might choose not to have any phone service under option 1. So the best is the best indifference curve. Right. Like this. Let's write down that this is your maximal utility under option 1. And under option 2, we know that more is better. Yes, more is better. So where we will move if we will choose option 2? Somewhere here. Okay. And this will be maximal level of utility under option 2. That's all. This for point C. Questions about this, please? Okay, we will continue the next time our problem 4, and I will explain to you this optimization program one more time. Why we take these points, best points for us. How we maximize our utility subject to our budget constraint. Okay, so we'll start the next class with number 4. Okay.
Great. So, thank you so much.
Thank you.
Thank you.
But today, can I check? Today, I was talking with Alex, with Sophia, and with Elizaveta. Yes. And that's all. Who also answered? I did not write down. I think that's all. Yes. Okay. So thank you so much.
Yeah. Thanks so much.
Thank you. Goodbye.
Have a wonderful day. Bye.
Yeah. You too. Goodbye.